Due to technical difficulties, this is density in 3D part 2. Alright, so we're doing number 6 on the back of our notes. On number 4 and 5, we already confirmed. Well, number 4, that should have been easy for y'all after you did your volumes. Chris, just to recap on number 4, what did you get? Which shape had the highest density? The cube, and what was that density of that cube, if you don't mind? Perfect, thank you. 1.72, and it had the highest density. Alright, yeah, I see. You need a little pressure there. Alright, number 5 should have been easy for everybody. Please don't break that. Number 6. A city pool worker wants to put chlorine in a recently filled pool to meet the desired chlorine density of 1.5 milligrams per liter. The pool is 6 meters wide, 12.2 meters long, and has an average depth of 2.4 meters. Use the fact that 1 cubic meter, this is part A, excuse me. I'm going to read it separately. Part A, use the fact that 1 cubic meter is equal to 1,000 liters to determine how many milligrams of chlorine per liter the city worker needs to put in the pool. Round your answers to the nearest tenth of a milligram. Explain your reasoning. We're not going to explain reasoning on number 1, part A though. I don't need to cut that out. But on part A, we do need to recognize this part right here. It's going to be important for us. It says 1 cubic meter equals 1,000 liters. That's going to be important for us as we get ready to solve this. First things first though, we're doing mass, I think. That's what we're solving for here. Yeah, they already gave us density, and we need to find our volume. God damn. Alright, so like I was saying, you already got density, you're trying to find mass, so you need volume. Dior, what shape is a public pool usually? Rectangular prism. So we need to find volume of a rectangular prism. They gave us measurements. Volume equals capital B times H. Volume then turns into, what's the capital B? L times W times H. Thank you. Let me zoom in a little bit because I'm going to be writing kind of small over here. Preserving a little bit of space. Volume equals, my length was 6. My width was 12.2. And then they said the depth or my height was 2.4. All that being said, once you multiply those together, one of y'all two already got to give it to me. A little bit louder. That is not what number I need. 17 what now?
175.68.
That's 0.68, and this would have been meters cubed. This is where the issue lies at. They don't want our volume in meters. They want it in liters. So that's why they told you what they told you at the beginning of this problem. It says 1 cubic meter is equal to 1,000 liters. So that's the adjustment that you need to make at this point. After you find your volume in meters, change it to liters. To change it to liters is not that hard. They say 1 cubic meter equals 1,000 liters. If that's the case, I want to multiply this times 1,000. What, man? Huh? Well, you can give me that, yeah. I mean, that's just gonna give me my new volume. Yeah, this is liters cubed. Alright. So that's the volume I'm gonna use. That's the adjusted volume. Then from there, now I can do density equals mass over volume. My density was 1.5. This is milligrams per liter. Then my mass I don't know. We just found our volume was 1,775,680 liters cubed. And then from there, y'all should know what to do. From there, y'all should know what to do. Multiply on both sides. Read some back recordings, so it'll be cool. Cancels, and then you'll get your mass in milligrams. Number 6, Reese. You can spit it out, man. I'm listening.
263,520.
Thank you. This is going to be milligrams, if you care. So that is the mass, my bad. That is the mass of the chlorine in a pool. Alright. Then after that, part B is working off part A. But it says, suppose the dimensions of the pool are doubled. Would twice the amount of chlorine be needed? So this is not just a yes or no question. To prove yes or no, you have to actually solve this. I've seen some kids, when we've done this before, and then some kids, they just writing yes. You don't know that, and honestly, it ain't yes. One thing this is trying to show you is something about volume. I had a kid ask me in another class the other day because he thought he could just shortcut his work. He was like, well, since the dimensions are doubling on my volume, on my figure, isn't the volume just going to double? No, that's not how volume works. Just because I double like the numbers, like say if I change my radius from one cylinder from 2 to 4 and I kept everything else the same, that don't mean that the cylinder just doubled. It actually increased larger in size than just doubling. Yeah, so we gotta figure this out. On this one, the volume formula is still the same, length times width times height. It's just that they want us to double the dimensions. So our original dimensions for our pool, we're gonna double them. So my original first dimension was 6, so what am I changing that to? 12. And then 12.2, what am I changing that to? 24.4. And then the last one was 2.4. 4.8. And then that'll give me my new volume in meters. And then I ain't on that page. Oh, wrong color. Some of y'all got this. Only thing with that, same thing as last time though. That's in meters. We need to turn it to liters. So times 1,000, and we need to change the volume. The volume would be 1,405,440 liters cubed. So that's the volume we're going to want to use right there for the new pool. Then after that, go back over here. We're going to calculate our mass again, and then we'll compare. So density equals mass over volume. Density is going to be 1.5 mg's per liter. I'm setting up the same way I set up the first one. I don't know my mass. My volume is this new volume I just calculated down here. 1,405,440 This is liters cubed. And then we multiplying on both sides. Times this. Cancels. Times it over here. Your mass you'll get is 2,108,160. It's gonna be mg's. I don't want to box this though because that's not what they asked. They ain't asked me for math on this one. On this one, they wanted to know would twice the amount of chlorine be needed. To figure that out, my new number here, I'm gonna take it and divide it by my original mass. Take this number divided by this original mass up here. That'll tell you how many times the amount of chlorine is needed. Those who already did it, what y'all got? What? Faith, what did you get on this problem? I know that already. You didn't divide right now. Anybody divided yet? Come on, bro. Chris the closest. Think you should just get 8, right?
I got 20.
You should get 8. If you're doing anything else, you're doing it in the calculator wrong. If you're doing anything else, you need to recalculate your stuff in the calculator. So on this one, I said no. And I said you would need 8 times the amount of chlorine, basically. Not 2. Faith. So I'm looking at practice. Come on, man. You can't gum it with that, man. Alright. Number 2, it says the density of carbon tetrachloride is 1.59 grams per milliliter. It says calculate the volume, so they want us to find volume of 26,400 milligrams of the liquid, round to the nearest thousands. So they gave me density. They also gave me mass here. I don't want you to think this is volume. This is mass, what they gave me right here, because they told me to calculate volume. So obviously that's missing. Some of the other problems are going to read like this too. You need to make sure you understand what you're looking for. They're not giving you volume. They didn't say this was volume. They said calculate the volume of 26,400 milligrams of liquid. So this is mass. Other issue here. My mass is in milligrams. My density is in grams. Can't have that. One of those need to be converted. The easier conversion to do is going from milligrams to grams, though. So let's do that. Where am I at? I'm sorry. So, for every 1 gram, there's 1,000 milligrams, or vice versa. If that's the case, to convert this to grams, I'm gonna do 26,400, excuse me, divided by 1,000. That's gonna take me from milligrams to grams. Once I do that, that'll be 26.4 grams. That's the number I want to use for my mass in this problem. Then after that, then you solve for volume. You should be able to do that part on your own. But that's what you want to use for your mass right there, 26.4 grams. On the back, real quick too, it's only one more I need to show you. I'm going quick. On the back, number 1, home learning, it says a graduated cylinder was filled with 25.0 milliliters of water. A solid object was immersed in the cylinder, raising the water level to 32.9 milliliters. The solid has a mass of 69.2 grams. What is the density of the object? Round to the nearest thousand. So on this one, they give you mass. They tell you the mass is 69.2. They want you to find density, but you're missing volume. But to help you find volume, they told you how water reacted to an object, the object falling into it. They said they had a cylinder of water in it. It was at 25.0 milliliters. Then once they dropped the solid object in the water, it changed to 32.9 milliliters. They're doing that to help you find volume. So you got to do the subtraction yourself. The volume on this one would be the change in the water. 32.9 minus 25.0. And then the volume would be 7.9. What is this? Milliliters. That's the volume you want to use. They already gave you mass, you need to find density. Alright, everything else should be straightforward on there. These two I just know have always been problems in the past that people have come up and asked a lot about. So to counteract everybody coming up to me asking me about the same two things,